Another factor which we need to look at also is that the actual shape of the trout's body is formed of a composite of 3 egg forms. There's one seen from the side, viewed from the top, and viewed from the front. Now, this egg shape seems to have an affinity with vortical flow, and it offers less resistance to flow than other shapes do. And we will also have a look at this perhaps a little later on another diagram. But with the mathematics of Walter Schauberger, who was Viktor Schauberger's son, a physicist, it's possible also to create similar egg-shaped forms, fish forms. And these just show some which I created on my computer, these ones. And that is by combining 2 eggs and forming the third one, which is what you see from the front. So you can see that these shapes actually are very fish-like, and they are as a result of Walter Schauberger's mathematics, which we will address a little later on. Now, in his remote forest house, Viktor didn't have any power, and of course he wanted to have electricity, and this was one of his very first inventions, a water jet turbine, in which he was able to generate a certain amount of energy, electricity, using only 1/10 of the normal amount of water required to produce the same amount of power with conventional systems of hydroelectric power. The water was made to flow down this rifled conical pipe, where it impacted on an impeller, which is this rather shell-like form here, and the impeller in fact was made of grooves which faced upwards, so when the water impacted on them they caused a rotation, and these tails at the end of it were where the last bit of momentum of the water was captured, and then the water just fell off, and this was extremely efficient, as I said, and it produced a 9-fold increase in power for the same amount of water. A group of people, enthusiasts in Austria, whom I visited when I was there, were building a combination of egg shape and hyperbolic cone. Again, we'll come and talk about these later. But they were going to put, I think, this impeller at the bottom of it to generate energy. That was their... they hadn't actually got the thing fitted when I was there, but there's an egg here, and then it turns into a hyperbolic cone, which is actually a cone with curved sides. Later on, the egg shapes, as we're still sort of on the subject of egg shapes, they became very important for Viktor's devices. This is a device built in Sweden for purifying water and for raising water from sort of standard surface water quality to high-grade spring water quality. There's no diagram inside this one, but the following diagram is nearly the same, and it'll give you an insight into what was actually happening inside there. The most important ingredient in high-quality spring water is carbonic acid or carbon dioxide, and that comes in through this pipe. Now, the normal surface water is brought in around the side here, and it feeds up through these sort of nested rilled bowls, and these are caused to rotate, and in the process of rotation they are forced towards the outside with centrifugal force. At the same time, because of the waviform nature of the space between these two, they're also made to rotate in a centripetal fashion, so that the water is exposed to both centrifugal and centripetal force, again using the two forces in conjunction with each other. Coming into this cavity, a vortex is formed inside, and the carbonic acid or the carbon dioxide, whether it is carbonic acid or carbon dioxide is again dependent on temperature and pressure, is fed in, and because of this vortical movement it is actually sucked into the water. It's not put under pressure, and so that with a system like this you could create your own mineral waters, your own true mineral waters, but the bubbles would stay in there. They don't come off when you take the lid off, because the carbonic carbon dioxide, I'm sorry, has been infused under natural process into the water. So that was the principle of the previous Swedish machine that we saw, but this one was also used for raising water. And the water, once by making this movement, was endowed also with this levitational energy that we spoke of before. And at a certain point, when the energy is high enough, when it has reached a certain point, then the water rises up the central pipe. All that was needed to drive this was a fairly modest electric motor. And according to Viktor, the water could be raised to almost any desired height with this process. There is more involved in it, but I don't think I'm going to be able to go into that because there are other things that I also want to address with Viktor's work. One of the ways of testing the quality of water was this double water jet gadget, which he built first, or his son Walter Schauberger built first in Nuremberg in 1938, although I think it's a development of Lord Kelvin's original experiment early this century or in the late 19th century. Here, through two needle jets, I mean these are hypodermic needles, water is made to fall through two insulated cylinders with brass lined into two receptacles, which are also made out of, they're also insulated. In this case they're insulated with paraffin wax, but each of them has a brass strip in the bottom which is connected diagonally to one of the, or other of the cylinders. And when water falls down through there, at first you see the jet come straight down, and then after a while you can't see the water appear below here at all. It disappears. A charge builds, and if you connect bring two wires together, one with a positive charge and one with a negative charge, you can get a spark which will jump about an inch. I got that now. In terms of voltages, that is about 60,000 volts. And Viktor used this machine to determine the quality of water, because it could also be employed in conjunction with what is called an electroscope, which detects the presence of a static, either positive or negative field in the atmosphere, and then there's a part of it which flaps every time it is exposed to the field, so to speak. You bring one of these wires, you touch the top of the electroscope, and then it flaps up like that and then drops away. You touch it again and so on. Well, now with this machine, 1 liter of very high quality water could be passed through it 150 times before the electroscope stopped flapping, whereas low quality water would only maybe pass through 5, 6, 10 times and then the thing would stop flapping. So he used it to determine the life force within the water. Another facet of this gadget is that it shows you again what happens in thunderstorms and how the charge is built up in thunderstorms, how the updrafts and downdrafts are created in thunderstorms, because the water actually, you see, when like charges repel each other, so when it's falling down through from the jet at the top, a charge is generated and all the like charges repel each other, so gradually the water molecules move away, and as a field builds at the bottom, then they can't go down, they have to go up, and so you have this movement which eventually also can be a circulation. And in the middle of this, I suppose, you can also have this electric discharge, which shows you in a very simple form how lightning works and why it occurs up there, and why it also can be so huge. Because you have to think that this is not, as a machine is about this high, the fall distance is about this far, and with that I was able to generate a spark which jumped an inch. Now that's, as I said, 40 to 60,000 volts. Then Viktor also, towards the end of his period, built these two, they're so-called flying saucers. This one, either one of them, I think, flew. They're both actually the same machine, but they've got different caps on them. He kept on modifying it. This was either called the repulsine or the repulsator, because the forces were active in them were the forces of recoil, of retropulsion. And these were achieved again using centrifugal force and centripetal force operating on the same axis. And in the following diagram it will become a little bit more apparent how that works. because this one is to do with the biotechnical submarine, as he called it.